Tutorial: Idea to prototype, build, and evaluate an enterprise agent. This tutorial covers the first stage of Microsoft Foundry developer journey from an initial idea to a working prototype. You build a modern workspace assistant that combines internal company knowledge with an external technical guidance by Microsoft Foundry SDK. Business scenario: Create an AI assistant that helps employees by combining company policies from SharePoint documents, technical implementation guidance from Microsoft Learn via MCP, complete solutions combining both sources for business implementation, batch evaluation to validate agent performance on realistic business scenarios. Tutorial outcome: what you will get from this. By the end, you have a running modern workspace assistant that can answer policy, technical, and combined implementation questions, a repeatable batch evaluation script, and clear extension points, other tools, multiple multi-agent patterns, richer evaluation. You will build a modern workspace assistant and with SharePoint and MCP integration. You will demonstrate real business scenarios combining internal and external knowledge. You will implement robust error handling and graceful degradation. You will create evaluation framework for business focused testing. You will prepare foundation for governance and production deployment. This minimal sample demonstrates enterprise-ready patterns with realistic business scenarios. Code in this article uses packages that are currently in preview. This preview is provided without a service level agreement. We don't recommend it for production workloads. Certain features might not be supported or might have constrained capabilities. For more information, see the supplemental terms of use for Microsoft Azure previews. Prerequisites: an Azure subscription. If you don't have one, create one for free. Azure CLI 2.67.0 or later, authenticated with AZ. Check with the AZ version. A Foundry project with deployed model, for example, GPT-4o Mini, 4o Mini. If you don't have one, create a project and then deploy a model. See model overview, model catalog. Python 3.10 or later, and .NET SDK 8.0 or later for the C# example. SharePoint connection configured in your project. SharePoint tool documentation, you can refer to that. Note: to configure your Foundry project for SharePoint connectivity, see the SharePoint tool documentation. Optional: git install for cloning the sample repository. SDK versions and sample repository structure may change after publication. Before you begin, check the sample repository README for the latest setup instruction. Require package versions and environment configuration. If a version reference in this tutorial isn't available on Pi or NuGet, use the latest published version instead. Step 1. Get the sample code. Instead of navigating a large repository tree, use one of these approaches. Option A. Clone the entire samples repo. Code uses Azure AI Projects 2 version 2 and is incompatible with Azure AI Projects version 1. See the Foundry Classic documentation if you want the version 1. So this is how you clone it. You git clone, you give the depth 1, and then you clone it like this, Foundry samples 1, then you go into this project folder. Then there is an option B, sparse checkout only this tutorial, reduce the download. So git clone, no checkout, and you download this. Then you go to the Foundry samples folder and you hit git sparse init with the tag of cone. I'm not sure what that means. So again, you set samples as checkout, then you actually check out, and then you go to this folder. Option C is download zip of the repository. Download the repository zip exactly to your local environment and go to the tutorial folder. For production adaptation, use a standalone repository. So if you want to adapt this production, use a standalone repository. This tutorial uses shared samples repo. Sparse checkout minimizes local noise. So you can download this here. After you extract the zip, go to the samples Python enterprise agent tutorial, one idea to prototype. The minimal structure contains only essential files. So you go to this enterprise agent tutorial, there is one idea to prototype folder, and there is env, which has created this file local environment variables, and there is evolution by which has the business evolution framework. Then there is main modern workplace assistant in the main pie, which is the main logic, and then there is question JSL, which is business test scenarios. It has 4 questions, and then there is Python dependencies which you have to download to run this project, and then you have the SharePoint sample data where you can which is actually used as the resource. Run the sample immediately. Start by running the agent so you see working functionality before diving into the implementation. So the working functionality is basically asking question and answer regarding your business documents, as well as the implementation details and the complete solution that which happens by combining both. Environmental setup and virtual environment. Install the required language runtimes, global tools, and BS extensions as described in the prepare your development environment documentation. Verify that your requirement doc text uses these published package versions. So Azure AI projects and python.env. Check that. Install dependencies. You can install by python dash m pip install dash r requirement.txt. Verify the install succeeded. You should see successfully install Azure AI blah 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 Python for the Python, and restore completed without no errors for the .NET. Find your project endpoint on the welcome screen of the project, which is, you can see the project right here. Configure the env. Set the environment values for your language. Copy the env.template to the env, and add this Foundry project endpoints. It should start with the https:// your project and the aiservice.azure.com. Foundry model should something like GPT-4o mini. The Microsoft Learn the MCP server, which is optional. MCP server URL should be something like http://learn Microsoft/API/MCP. SharePoint integration optional, requires connection name. SharePoint's connection name should be your exact connection name. Probably you have to check the SharePoint documentation that was mentioned earlier. Confirm.env contains valid values by opening file and verifying that the Foundry project endpoint starts with http:// and the Foundry model name matches the name of a deployed model in your project. To get your tenant ID run az account show --query tenant ID -o_t3. To get your project endpoint, open your project in the Foundry portal and copy the value shown here. Run agent and evaluation. Python main and Python evaluate.py. Expected output agents first run. Successful run with SharePoint. Creating a modern workspace, so it will just run and it will show you the creating modern workspace as per the code. Then SharePoint tool configured successfully, then the agent created. If there was an error or you didn't provide something like this, you will get something like SharePoint integration skipped. So it will still create that agent. Now that you have a working agent, and next sections explain how it works, you don't need to take any actions while reading the sections. There are 4 explanations. So you already run this actually. So this is just for the explanation. Set up sample SharePoint business documents. Go to your SharePoint site, configuring the connection. Create document library, company policies, or use existing documents. Upload the 4 sample Word documents provided in the SharePoint sample data folder. Remote work policy, security guidelines, collaborations, data governance. Verify that your 4 documents appear in the library before proceeding. Sample structure, company policies should have these 4 documents. Understand the assistant implementation. This section is for reference only, no action needed. It explains the code you already ran. This section explains the core code in MainPy or Modern Work Assistant program.cs. If you're using C#, you already ran the agent. After reading it, you can add new internal and external data tools, extend dynamic instructions, introduce multi-agent orchestration, enhance observability and diagnostics. So you can do these. The code breaks down into the following main sections ordered as they appear in the full sample code. Configure the imports and authentication, configure authentication to Azure, configure the SharePoint tool, configure MCP tool, create agent and connect tools, converse with the agent. That's the last step. Important point to note, code in this article uses packages that are, we already know that, imports and authentication set. The code uses several client libraries from Microsoft Foundry to create robust enterprise agent. So first you have this operating system time, then you have Azure AI project client from the AI projects, then you import the project agent definition, SharePoint preview tool, SharePoint grounding tools parameters, tools project code connection, MCP, all these from the AI projects models. Then you get the default Azure credential from the identity, then you have the load.env from the .env, and then you have the MCP approval response, how the response should be, and that is also from the open types responses response input param. Configure authentication in Azure. Before you create an agent, set up the authentication to the Foundry. So you have this credential, you have this project client created using the credentials that you have used, you created, and then you have the OpenAI client using the method that is coming from the project client, which also have the credential in it. Create the SharePoint tool for the agent. The agent uses SharePoint and can access company policy and procedure documents stored there. Set up the connection to the SharePoint in your code. So how do you connect it? You get the connection ID from the ENV, then you have the tool, then if the connection is there, you go there, you use this SharePoint preview tool method, you into that you pass the SharePoint grounding preview. With that you call a method called SharePoint grounding tool parameters, will return the SharePoint, actually this will return the SharePoint grounding tool parameters. You pass in the project connections, within that you pass a list object which returns something like project connections. So here you pass in the what you call tool project connections, and for that you need the projection connection ID, which is the SharePoint connection ID. Then if it is created, you will get this. If not, you will have to make it null. None. Create MCP tool for the agent. So again, it's the same thing. You do the same thing, almost the same steps, for just you did different same thing. Create agent and connect tools. Create the agent and connect the SharePoint and MCP tools. So you have done that. So if there is a tool, then you add it to the tools, you add everything to these tools, append it, and then you create the agent from the project client. Agents create version, you give the agent name, you give the definition, and in the project agent definition you pass in the model, instruction, and the tools. Then if the tools everything is success, you get this message, agent is created successfully. Converse with the agent. Finally, implement an interactive loop to converse with the agent. So print agent response, create agent response, you call that method, and you pass in the agent, you pass in the scenario, you pass in the OpenAI client. Expected outcome from the agent sample code. When you run the agent, you see output similar to the following example. The output shows successful tool confirmation and agent response business. So you see this again, you see everything again, everything is connected, agent is successfully created. Then you ask questions. You ask what is the control source remote working policies, and you get the answer. Again, you ask another question. For the second scenario, you ask the question like, according to Microsoft Learn, what is the correct way to implement AD conditional access policy? Please include review reference links and official document. You ask this question and it answers. It gives you an answer. Agent response to implementation, it gives a particular answer. Understanding conditional access, so that from here to here the answer is there. After that, status is completed. Same thing based on our company's remote. So this is the combined implementation question where both implemented, both are combined. So you ask question based on our company policies, how should I configure Azure environment to comply? Please include links to Azure documentation, Microsoft documentation, and it answers your questions again. So demonstration completed. Key learning outcomes: Microsoft Foundry SDK usage for enterprise conversation management via responses API, real business value for AI assistant, foundation for governance and monitoring. So tutorial 3, these are the things. Try interactive model, yes or no? No. Sample completely successful. This foundation supports tutorial 2 and tutorial 3. So it supports. So if you are going to the tutorial 2 and 3, this foundation is needed. Next, and add evaluation metrics monitoring. So the next step, you can add the evaluation metrics monitoring and deploy production deployment. Evaluate the assistant by using batch evaluation. The evaluation framework tests realistic business scenarios by using the batch evaluation capability of Microsoft Foundry SDK. Instead of a custom local approach, this pattern uses built-in evaluators, built-in violence, built-in fluency, built-in task adherence, and the built OpenAI client evals API to run scalable, repeatable evaluation in the cloud. This evaluation framework demonstrates agent targeting. The evaluation run queries directly against your agents by using Azure AI target completion, built-in evaluators, safety, violence, so whatever that I said, quality, task adherence metrics, cloud-based execution, eliminates local compute requirements and supports CI/CD integration, structured results. It will show you pass or fail scores. All these metrics will be given by this evaluation framework for each test cases. The code breaks down the following main sections: configure the evaluation, run the batch, retrieve the evaluation results. For detailed guidance on batch evaluation, see Run Evaluation in the Cloud. To find a comprehensive list of built-in evaluators available in Foundry, see the Observability and Generative AI. The C# example uses local batch evaluation approach with project responses client instead of the client OpenAI client evals API shown in the Python. It sends queries to the agent, checks the response against the expected keywords, and writes results to the evaluation results JSON. See the C# evaluation SDK sample for cloud evaluation patterns in C#. So these are different, so they are just mentioning that. Configure the evaluation. First, create an evaluation that defines your data schema and testing criteria. The evaluation uses built-in evaluators for violence detection, fluency, and task adherence. In Python, use OpenAI client directly. In C#, get an evaluation client from the project client. So in the Python, you can simply do this. You get the endpoint from the project endpoint. You get the model deployment name from the Foundry deployment name. Then you do this, you get the project client, then the project client, you get the create version, you get the agent here, create or retrieve the agent to evaluate. Then after that, you define that schema for evaluation. How do you do that? Data source config custom. You pass a type called custom. Then you give the item schema, which is object, which has a query, which is string, and whether the query is also required. Include sample schema, of course, true. Define testing criteria with built-in evaluators. Testing criteria is Azure AI Evaluator. You are testing for violence detection. An evaluator name is built-in violence. You already see this. So data mapping will be for the query, and the response will also, I think, sample output text. I'm not sure how that, but it will check for the violence detection. It will check for the fluency. It will check for the task adherence. At the end, create the evaluation object. OpenAI, you pass in the name of the evaluation, and then the data source config, you pass in the data source configurations, and the testing criteria, you pass in this testing criteria. Then you have something called eval object ID and eval object name. You have the name and the ID. The testing criteria array specifies which evaluators to run. Built-in violence detects violence or harmful content in the response. Built-in fluency assesses response quality and readability, requires a model deployment. And built-in task adherence evaluates whether the agent followed the instructions correctly, whether you ask something and it's adhering to the task that you actually give them originally. Run the batch evaluation. Create an evaluation run that targets your agents. Create an evaluation run that targets your agent. Run the batch evaluation. Create an evaluation run that targets your agent. Okay. Create an evaluation run that targets your agent. Run the batch evaluation. Okay. Create an evaluation that targets. So you are creating an evaluation that will target your agent. The Azure AI target completions data source sends queries to your agent and captures the response for evaluation. So this sends queries, and the response will be evaluated by the evaluation, which we probably the batch evaluation. So you have the data source here, which has the Azure type of Azure AI completion. Source is equal to file content, and the content has these questions. Then the input message is type is equal to template. Source input message is template, and it has the role of a user. Content is equal to text. Then you have the target, which is the Azure AI agent, and the agent name and version are given here. Create and submit the evaluation run. So for the eval run, the type will be create response and create retrieve response. And the evals runs create, you pass in the eval object ID and the evaluation and just a name. Then you pass in the data source, which is this, which has the queries as well. So evaluation run created, agent evaluation run ID. You give the ID. The data source configuration type. So this data source configuration, the type here is, so this routes the queries to your agent. Source is the inline content with test queries. You can also use a dataset file ID for this. Input messages template that formats each query for the agent. Target, so this input messages is just basically template the formats. Target, specify the agent name and version to evaluate. specify the target is the target. Retrieve evaluation status. How do you do that? Pause the evaluation run until it completes, then retrieve the detailed output items. So while agent eval run status is not completed or failed, that basically means it is running. Agent eval run OpenAI client evals runs retrieve run id agent eval dot run id eval id. Okay, so eval run. So what you do is you retrieve using the eval run id and the eval object, then waiting for eval to complete. Current status is equal to something. So if it is not completed, it will run. So after this you get the eval run status completed. If it is completed, you get the results. Okay, you get the results. Output items is equal to, you get the list which will have the output items, and then you print it, and then you have all this stuff. So after that you have to clean up. So OpenAI client evals delete eval using the delete the evaluation object using the id, then the evaluation will be deleted. Then after that also delete the agent. So project client agents dot delete agent's name, just using the agent name you can delete it. Each output item includes label, binary, pass or fail result, score, numeric score on evaluator scale, reason, explanation why the score was assigned for LLM based evaluators. Expected output from batch evaluation evaluate.py. When you run the evaluation script, you see output similar to the following example. The output shows the evaluation object creation, run submission, and the results created. So when you run this, agent created will come first, then the evaluation created, then the evaluation run was created, waiting for eval to complete, then the evaluation complete successful, then the results will be shown. How many passed? 2 passed, failed 0, errors 0. Output items. So when you print the output item, you will have this, what is the largest city in the France, and then the output text will be the largest city in the France is Paris. So violence detection passed true, score fluency is equal to 4, response response is clear and well structured, so it's well structured, and task adherence true. For the task adherence I asked for a larger city, it is giving me 5 results. So eval run report, you can go to this somewhere and check it. Evaluation deleted and the agents also deleted at last. Understanding the evaluation results. Batch evaluation provides structured results that you can view in Foundry portal or retrieve programmatically. Each output item includes. So batch evaluation provides structured results that you can view in the Foundry portal or retrieve programmatically. Each output item includes, so you can see label. So label whether it's passed or failed, then the score, then the threshold, the cutoff value that determines the pass or fail. So there you saw the score, right? Like if it is 5, it's pass. If it is 1, it's fail. Something like that. LLM generated explanation for the score when applicable. So you can see that there is a reason. This response is clear and well structured. That is the reason that you have. Score scales by evaluator type. Quality evaluators, fluency, coherence. So quality evaluator is basically fluency and coherence. You saw that. Safety evaluators, violence, self-harm, 0 to 7. So the scale is 1 to 5 for the quality. Safety, you have 0 to 7 scales, severity scale. Low is safe. So you have 7 that you have very severe scale. Task evaluators, task adherence, you ask something, if it is doing that, 1 to 5 scale rating. You can also view detailed results in the Foundry portal by selecting evaluation from a project and selecting the evaluation run. The portal provides visualization, filtering, and export options. You can view detailed results in the Foundry portal by selecting evaluation from your project and selecting evaluation run. The portal provides visualization, filtering, and export options. For production scenarios, consider running evaluation as part of your CI/CD pipeline. See how to run an evaluation in Azure DevOps and continuously evaluate. So, you can also view detailed results in Foundry portal by selecting evaluation. You can also view detailed results in Foundry portal. So, this can be actually viewed in the Azure portal. Evaluation by selecting evaluation from the project and selecting the evaluation run. The portal provides visualization, filtering, and export options. For production scenarios, consider running evaluation as part of your CI/CD pipeline. See how to run an evaluation in Azure DevOps, And continuously evaluate your AI agents for integration patterns. Continuously evaluate your AI agents for integration patterns. Troubleshooting. So troubleshooting, you have the Azure default symptom, Azure default credential authentication error. So if there is something like Azure default authentication error, the code should be Azure CLI expired, not signed in. So something like that. Run Azure login again, retry again. Model deployment not found. Model name in the .env file that does not match your deployment in your project. So open your project in the Foundry portal and check deployments and update your Foundry model name in the .env. SharePoint tool configured, but agent can't find documents not uploaded, or connection name is incorrect. Verify documents appear in the SharePoint library and that SharePoint connection name matches the connection in your project. MCP tool timeout or connection error. Microsoft Learn MCP server is unreachable. Verify MCP server URL is set to https learn microsoft.com API MCP that your network allows outbound HTTPS. 403 forbidden on SharePoint. Insufficient permission on the SharePoint side. Confirm your signed in identity has at least read access to SharePoint document library. So these are the things that you have to worry about if there is some sort of errors. Summary. Now you have a working single agent prototype grounded in internal and external knowledge, a repeatable evaluation script demonstrating enterprise validation patterns, a clear upgrade path, more tools, multi-agent orchestration, richer evaluation, deployment. These patterns reduce prototype to production friction. Prototype to production friction. You can add data sources, enforce governance, and integrate monitoring without rewriting core logic. So the next steps, you can go this, you can do this, you can do that. So these are the next steps.